Hey, this is Joel Duff. Welcome back to the channel. So, what are we going to talk about here? How about millions and millions of teeth embedded in phosphate rock in the Moroccan desert? Of course. What else would we be talking about? I saw this picture on actually Blue Sky. Somebody had shared this picture of these fossils, these approximately 5,000 Mosasaur teeth just in this picture alone. But this is but a very small sample of the numbers of Mosasaur teeth that come out of the phosphate rock of the phosphate mines of Morocco in the Moroccan desert. So what's up with this phosphate stuff? Why is it important? What's up with these teeth? Why are there so many of the exact same type of teeth all in a very thin layer of rock? And what does all that have to do with the age of the earth and flood geology? Because after all, I'm calling this an episode of flood geology failures. This is my only slide. I'm going to keep it short, keep it simple, hopefully. I just tweaked my interest. I knew about Mosasaur teeth. I actually have one from the Moroccan phosphate mines. And lest you be fooled into thinking that they are incredibly valuable, no, there are so many of them. They're really terribly overpriced given how common they are. But nonetheless, a Mosasaur tooth, pretty cool. You can see here, there's no way I'm paying $499 for 100 of them. Now, admit that these particular Mosasaur teeth are in pristine condition. All right, so that's a set of 100 teeth that's really in very, very, very good shape. And so they are worth a little bit more. In fact, if you were to look at on eBay, you might have to pay anywhere from $10 to $15 plus shipping for an individual tooth of a Mosasaur of that size and in that condition. So I guess if you want to fork out the $500, you could turn it right around and sell each of them for $15. Probably a little bit of profit there. Or you might go to for this other one down here, $88. $88 for 100 Mosasaur teeth. Now those are of lesser quality. They've been sorted out, and these aren't nearly as nice, and a lot of them are smaller. And of course, size is what everyone's looking for in these types of things. Like megalodon teeth, right? The biggest shark tooth. And you might be able to read it there, but if you want to purchase that set of 100, well, if you'd like to buy 2 sets of 100, it's only $83 each. And if you want to buy 3 sets, $79, and 4 or more sets, down to $76 for 100 of them. So a little less than $1 per Mosasaur tooth. So what's the big deal here? Obviously, if somebody can sell 4 sets of 100 for that price, and they've sold some, I don't know, I think I looked it up, they sold 18. Yeah, it says 18 sold. And there are many, many people selling batches of Mosasaur teeth. That tells you there's a lot of Mosasaur teeth in this world. There's a whole lot of them around, especially in the Moroccan desert. Mosasaur teeth are also found in many other locations on Earth. And interestingly, everywhere they're always found from the same geological period, basically the Cretaceous. They're present a little bit before the Cretaceous, but mostly they hit their highest diversity in the Cretaceous period. So whatever continent you're on, in Cretaceous rock, but specifically Cretaceous rock that's marine, has other marine organisms, you can find Mosasaur teeth. Mosasaurs are a little bit like sharks in the sense that they lost teeth over time and then continually replaced their teeth. So that's that's one of the reasons why there's so many sharks' teeth, because sharks have a lot of teeth and they're constantly losing them, right? They're constantly dropping out, and so then falling to the bottom of the ocean, all right, and building up there. So there's many places where there's a lot of sharks' teeth, and Mosasaurs are in a similar way. But that brings me to the connection with flood geology and the age of the earth. I see a picture like this, and where my mind wanders. It's like, how do different models of the origins of fossils explain this massive load of Mosasaur teeth? There's actually different species of Mosasaurs that lived in the past in this area of Morocco. So there's different types of teeth that have been found. These are what you're seeing in this picture are all the same species. There's not enough divergence among these teeth to be able to say that they came from multiple species, because some of the other species have very different looking teeth. There was some, maybe 10 different species that at some point or time in the layers of rock in these phosphate beds in Morocco, at different layers have different mosasaur teeth in them. So that's an interesting little factoid. And when you add it up, tens of thousands, nay, hundreds of thousands likely of mosasaur teeth have been collected from this location. You might wonder, how come so many from this location? Well, for one thing, there's a lot of them present, right? There's just a lot of them there. It's just a very high concentration there. And we can talk in a minute about why that might be the case. But there are phosphate mines. Right? 75% of all the phosphorus that is mined from the earth is generated in Morocco. And an enormous amount of the total amount of phosphorus available to us, at least available through mining, is available from the deserts of Morocco. And so if you've put fertilizer on your lawn, or your soybean field is getting fertilized, very likely that some of the phosphorus that's part of that fertilizer has come from Morocco. Morocco is what keeps the world green. Morocco is what keeps our crops so productive. And the United States and many other developed countries are very reliant on this particular source. And as a result, they're constantly chewing away. They're constantly eating away at this phosphorus. And as they do so, and they sort, as they're grinding this stuff up and breaking open this rock and creating phosphorus to be able to take to the coast and put on the barges or on ships and ship off to other countries. As that sifting process occurs, there are those who pull out mosasaur teeth from that. So you're really only seeing the best of the best. I mean, there's lots of fragments and smaller ones and ones that, they're a dime a dozen, right? So they're just picking the best ones out. So when you see that there's thousands for sale or tens of thousands for sale, and then you know that there's a vast number of additional ones there. And those particular deposits of phosphorus are somewhere in the range of potentially above 100 billion tons of phosphorus from that particular formation. And almost all members of that formation appear to have mosasaur teeth inside of them. And since they've only actually chewed up, a couple, like 50 million tons or something like that, you have a whole long way to go in order to use that resource, right? The phosphorus is a somewhat limited resource on Earth. Eventually, we're going to have a peak phosphorus situation where we're not able to extract phosphorus at the rate that to keep up with the amount of fertilizer we need, but that's still a ways off in the distance. Point is that if you think there's a lot of mosasaur teeth on the market and we've already pulled out tens and hundreds of thousands of mosasaur teeth, that means there's tens of millions, if not hundreds of millions of mosasaur teeth in this particular formation. Hundreds of millions of mosasaur teeth. What does that tell us about the number of mosasaurs alive in the past? All right, these mosasaurs, some of them were quite large. The famous mosasaurs are an absolutely enormous, 50-foot long type things, have elongated jaws. You can see this one here in this picture has about 10 to 12 teeth, per row on each side of the jaw. So let's say it's 10 for easy math for me. 10, 20, 30, 40 teeth in its mouth at one time, but then it might go through several different sets of teeth over its lifetime. So maybe during the lifetime of a mosasaur, it's making several hundred teeth. But not all mosasaurs are this large, although some are larger, and they might have as much as 100 teeth in their mouth at any one point in time. And so they may produce 1,000 teeth or more during their lifespan as well. So that's a lot of teeth. And that also explains why there's a lot of teeth that are found without any other portion of the body, right? It's like the teeth fall out as they're chomping on giant clams and ammonites that are swimming around. Those are ancient ammonites they're extinct organisms today, but we know that they chomped on ammonites because we have found ammonites and clams that actually have little puncture holes in them that are these round, from these conical teeth puncturing into those things. And so we're where do you find those types of fossils? You find them in the same sediment layers that you find the Mosasaur fossils, bones and jaws, and also Mosasaur teeth. Right? So there are layers of rock in marine sediments where these particular organisms are found. Right? And you see the direction I'm going here? We're thinking about I'm just giving you pieces of evidence. I'll say the observations of this world. And we're asking what might explain why so many exist in one place. So the conventional explanation for vast numbers of teeth and many fewer jaws and other components would be this, right? You have mosasaurs swimming around in a shallow sea at the time of the late Cretaceous, a shallow sea over northern Africa, what is now northern Africa. And in this shallow sea, an enormous amount, very abundant, very, very warm temperatures at the time, very abundant shallow sea life, ammonites, clams, all these different things in the water, right? Abundant food sources. And you had a bunch of mosasaurs. Now, you might be wondering about plesiosaurs and ichthyosaurs, the other sea reptiles. Remember, we're not talking dinosaurs here. We're talking sea reptiles, different branch of reptiles. And the ichthyosaurs and plesiosaurs are basically almost about gone, right? By this time, it's really the mosasaurs were really the predominant predator or reptile that was living in the ocean at the time. And so you have a whole bunch of different species of mosasaurs that live over the Cretaceous period. And as they live in the shallow ocean, and they're living for dozens and maybe potentially hundreds of years, potentially for each one, they're generating teeth, dropping teeth as they lose them as they grab onto prey, or just they age out and they're pushed out by teeth below. They fall down to the bottom of the ocean floor, along with all these remains of all these other many shelled organisms and so forth that are building up on the bottom. So, and they have lots of phosphorus in them. And so they build up many much layers of phosphorus laden material, which is preserved in these phosphate beds. Right, along with the teeth of these mosasaurs. All right, so and that's occurring over millions of years. So if you had several hundred mosasaurs, in a shallow sea in this particular area of Morocco, all right, a couple hundred square miles in inland Morocco, and you had several, let's just say we have a couple hundred mosasaurs. That's a lot. I mean, they're big organisms, right? And so you have a couple hundred living in a population then, and they're replacing themselves. And each one of them is making 1,000 teeth, right? And they're living there for thousands of years, potentially, although this shallow sea probably went up and down. So sometimes it was habitable by mosasaurs, and maybe other times it became too disconnected, too shallow, too saline. There's the evidence in the layers of phosphate suggests, climate change during this time, which sometimes was more palatable, less palatable for life there. But nonetheless, mosasaurs are probably able to live in this particular environment for tens of thousands, hundreds of thousands, really millions of years. And over those millions of years, millions of individuals have lived there, and they have lost teeth. And so we have millions of teeth. Right? As I was saying before, if you consider the entire volume of that deposit, and it's all from that particular age, that late Cretaceous period, and it's all an environment that would be amenable to mosasaurs living there, and mosasaur teeth are found in all the different areas that have been explored thus far. We're talking about a potential for tens to potentially hundreds of millions of mosasaur teeth being preserved in this location. And that would represent a whole lot of individuals. So now let's compare that to, let's think about in the young Earth creationist model, in which the Earth is only 10,000 years old or less, and 4,500 years ago, there was a global flood that was responsible for almost all the layers of the geological column. But certainly this layer would be included. Almost every young Earth creationist would include the Cretaceous as part of the flood deposits. For most young Earth creationists, this would be the late flood. Like near the end of the flood, these last layers were laid down. Now, if there was a giant flood and all of these fossils were laid down during that flood, that means these tens of millions of mosasaur teeth. There's lots of other fossils there too, but we're just talking mosasaurs for now. Those tens of millions of Mosasaur teeth all had to be deposited late in the flood year, basically all at one time within the space of maybe a couple of weeks at most. Right. And somehow they all got like these 5,000 in this picture and what is probably hundreds of thousands just from that one species are all found in a fairly distinct layer of that phosphate, because that represents one particular time in which this particular species lived. How does that happen in a global flood? This is why I call it a flood geology failure. Flood geology just fails to explain in a very profound way how you would get millions or hundreds of thousands of teeth all in one layer and not just found scattered throughout the whole geological column. Where were the mosasaurs during this flood? I mean, you might argue, well, they were swimming around, right? They were trying to escape the flood, and they escaped the flood for a long time, but they met their demise right at the end of the flood. I wonder, why didn't they survive past the flood? But there are no fossils past the Cretaceous. There are none in the post-flood record. So it appears that the flood, Noah's flood, wiped out all the mosasaurs. But they managed to survive to the very, very last moment. So we say, like, okay, well, then they all met their demise at one time, and that's why they're all found in one layer. Two problems with that. One is, if they all met their demise at one time, and they were quickly covered by the flood waters, why don't we find hundreds of thousands of individual mosasaurs, like, fully preserved? I mean, if they were just covered up, shouldn't we just have fully laid out mosasaur skeletons? I mean, we do have many mosasaurs that we have found. I mean, look at this one right here, right, off the Wikipedia page, right? And it's not, that's partly filled in. It's not every single original bone there. And so we do have some good samples, but mostly it's like a piece of a jaw here, a little bit there. All right. If they all met their demise at one time and they're quickly covered, why aren't they preserved for us in a way that looks like they were all covered instantly? But more importantly, it's the tooth thing that's the problem. Hundreds of thousands of teeth found independent of the organisms themselves. So what are we saying here? We're saying the mosasaurs were swimming around, thousands of mosasaurs of each species swimming around during the flood. And while they were swimming around, they didn't lose any of their teeth because, well, we haven't found their teeth in any other layers, especially this particular species, right? They're not found anywhere else. So all these other layers stacking up below, they're swimming around and they're looking down and they're not dropping any teeth. And then all of a sudden, oh, look, the flood's almost over. The last layers are being laid down. What do? Just spit all their teeth out and let them drop to the floor all at the same time? They're all like in unison, like, let's get rid of our teeth. And the teeth fall down and they all land in one layer. Even so, if there's several million teeth from one species, how many mosasaurs does that represent? They can only have so many teeth in their mouth at one time. The reason we can find so many teeth, we think, is because they're losing teeth over hundreds of years, thousands of years, millions of years, right? So it's not millions of individuals necessarily. It's a bunch of individuals that are making a lot of teeth. In the younger flood geology model, all those teeth have to come from organisms alive at the moment of the initiation of the flood. Right? Think about that. Where would the teeth have come from? I mean, even if there were teeth laying around before the flood, are we saying that the flood eroded the ground from before the flood where the teeth were in some other ocean and then lifted them up and they were floating around and they were like in the water? And then all of them decided to, let's drop out into the top layer. Even though they're different sizes, like some are smaller and some are larger, right? And they're really dense. Like, so why didn't they just fall farther down into the geological column? And then why are they associated with some fossils of bones with jaws that have the same teeth in them? So they all were floating, or they all were picked up from somewhere else. And then where the mosasaurs were swimming, they died at the same location where their teeth were transported to? Really? Is that what we're going to argue? I really don't know what young Earth creationists would say because they've never written about this particular instance. I've never heard an explanation. I'm really having trouble just conjuring up a potential explanation. I mean, I just did conjure up an explanation, and I doubt it made any more sense to you than it made to myself when I said it. So I consider this is a huge challenge. And this is what, people ask me all the time, like, are young earth creationists who are like, I mean, you can't explain this, and they don't even know about these types of things. They haven't really thought about these types of really simple evidences. Ken Ham was just like, all the evidence points on old earth. How does millions of mosasaur teeth point to a young earth? He would say, like, oh, well, lots of fossils point to an earth because that means there's the only way they could get preserved is a giant flood. No, these teeth do not need a worldwide flood to preserve them. Not at all. They preserve perfectly well at the bottom of a shallow sea, gradually being covered up. Right? They're preserved separate from the organism itself. So you know that they must be able to be preserved through some time separation from when the organism lost those teeth. Yeah. Anyway, this is so mosasaur teeth. They're pretty cool things, and there's a whole lot of them. Don't be duped into buying a $100 mosasaur tooth. Right? There's plenty more to go around, and there are thousands of mosasaur teeth from. I think from Alabama. There's places in Asia where they're found. I mean, there's multiple other locations, again, where there's Upper Cretaceous rock that's marine in origin. Usually there are mosasaurs. And where mosasaur skeletons are found, we also find an abundance of teeth. And so that itself is yet another issue. For young earth creationists. It's one thing to explain, maybe, I couldn't even explain this one location. But then when you add on, hey, there's 25 other locations where a similar mosasaur lived. And you also have an abundance of more teeth than you do the actual skeletons found in those locations. So it appears these mosasaurs were living in that location, right? They were living some kind of life. And as they lived, they dropped teeth in that habitat, where eventually they met their demise. None of that fits, right? None of that really works with the flood model, right? It's a real, how should I say? It's a real kick in the teeth to flood geology. I eagerly wait some kind of give me something to work with as a young earth creationist. What am I missing something? Am I missing some obvious hypothesis that maybe young earth creationists applied to some other organism that might apply here? I've looked up this shark teeth thing before, and I've never really found much of a discussion about that among young earth creationists either. Like, why so many hundreds of millions of shark teeth in the fossil record? And those shark teeth are different at different levels of the fossil column, or the geological column. Right? Why is there megalon teeth, but they're only found in a certain portion of the fossil record? All right. And then you have other layers that have other sharks living in them. Once again, how does the flood sort out sharks' teeth based on species? Sometimes there's bigger ones below smaller ones. Sometimes there's, different shaped ones at different levels. That's not a sorting thing. You would never sort those things in any way via any mechanism that we know about today, physical mechanism we know about today. So yeah, where do all those sharks' teeth come? Where do the mosasaur teeth come? Spinosaur teeth are also pretty common too. And we've got ichthyosaurs and all kinds of other things. A lot of teeth in the fossil record. They preserve fairly well. I mean, teeth do dissolve under the right, if the water is a certain pH and so forth. So we haven't preserved nearly all the teeth that organisms have made, right? But there are organisms that are represented by enormous numbers of teeth compared to the rest of the body parts. All right, I think that's it. I think that's enough for this episode of Flood Geology Failures. Yeah, hit like, subscribe, all that good stuff. I'll be back. Gonna be back soon because I'm finally out underneath some work from the semester, and I've had a little more time freed up. I have lots of ideas of things I want to talk about, but I have one major thing, which would be my long series on the Dead Sea, and we're going to be looking at the Dead Sea origins geologically, and we're going to look at the evidence from the Bible about what the Dead Sea has looked like over time, and how that relates to young Earth creationism. And so look for those videos. Believe those are going to be all on Monday nights at 10 p.m. Eastern time. Going to try to have a schedule. I'm actually going to try to have a schedule for these. So hope to join you. Hope to see you for some discussion on 10 p.m. on Monday nights. Until then, we'll see you when we see you. Bye bye.